This is part 5 of section 6.4. If u vector is defined to be 2i minus 5j, and the v vector is negative 3i minus 2j, we want to calculate each of the following. Now the good thing is that these work pretty much like regular algebra in that we can treat these as like terms and do the calculations with distributions and things like that. So if my u is 2i minus 5j, minus vector v, which is negative 3i minus 2j. This is essentially 2i minus 5j plus 3i plus 2j. And now combine like terms to get 5i minus 3j. Okay, now let's do 2v minus 3u. 2 times v, negative 3i minus 2j, and those are vectors, plus 3 times u, 2i minus 5j. Scalar multiplication distributes over vector addition and subtraction. So I get negative 6i minus 4j plus 6i minus 15j. Okay, now our I values cancel out, and I get just negative 19j. Now that's all they're looking for here, but if you're curious to write this as a position vector, it would simply be your I value is 0. So it would be 0, negative 19 if that's what you were asked for. Okay. Now, here we have 2v minus plus 3u, which is exactly what's right here, and then what the magnitude of that. So what do? I take the square root of, I square the two components and add them together. Well, 0 squared plus negative 19 squared. I don't even need to do the calculation of negative 19 squared, because if I take the square root of it, I'm getting 19. So that would be the magnitude of this vector. Okay, so now finally some trig. Okay, so vectors in terms of magnitude and direction. If we have a position vector, it doesn't matter which quadrant it's in, but if we have a position vector, so our initial point is at the origin, it goes off somewhere. If we define theta to be the smallest non-negative angle that v makes with the positive x-axis. Okay, so from here, the positive x-axis is here. This would be angle theta. We don't want to go in the negative direction, and we don't want to go around more than once, but it's just the smallest one that we have. Okay? If we have things defined this way, angle theta is called the direction angle. The magnitude of vector v, which is v1, v2, is described the same way it has been. That's the same. The direction angle is the smallest non-negative angle that satisfies tangent of theta equal to v2 over v1, where of course our v1 component is not 0. Okay. We can always write a vector v in terms of its magnitude and the cosine of the direction angle and the sine of the direction angle. Okay, this is called the trigonometric form of vector v. Okay. So let's look at some example problems we want to find the magnitude and the direction angle of each of the following. So if v, our vector v, is defined to be -4 cosine of 30 degrees I plus sine of 30 degrees j. Okay? So we can calculate these. This will be -4 times cosine of 30 degrees is square root 3 over 2 times vector I plus sine of 30 degrees is 1/2 j. Okay, so this will be -2 times the square root of 3 I minus, that's going to be 2j, and those are vectors. Okay, now what we want to do is we want to first think about what quadrant these would be in. So remember, we don't need exact, but this is our x coordinate and this is our y coordinate. And where x and y are both negative, that's quadrant 3. Okay, so my theta will be this angle, and it needs to be between 180 and 270. Okay, so we need to find the magnitude, which we find like this. The magnitude of vector v is equal to, we square these two and then take the square root of them. So this will be the square root of -2 square root 3 squared plus -2 squared. Okay, and this ends up being the square root of 16, which is 4. Okay, so I have the magnitude of this vector. Now I just need the angle, and what we know is that tangent of theta should equal this over this. So -2 over -2 square root of 3. And that means I need to find, my theta will equal the inverse tangent of, that is 1 over the square root of 3. Okay, inverse tangent of 1 over the square root of 3. This will give me 30 degrees. Okay, now remember when we were solving equations that we had a bunch of different possibilities, and for tangent, you had possibly the same answer, or anything else that might work is plus n. When we were solving before, we were doing it mainly in radians, so it was n pi, but here we're just going to add 180 degrees because we're in the 180 degree, we're in the degrees terms. If I add 180, 30 degrees is here. If I add 180, it is going to put my answer in the third quadrant, which I definitely need. So my theta answer that I am looking for is going to be 210 degrees. And don't forget your degree symbol. Okay, let's do the same thing with 12i minus 5j. So to find the magnitude of v, that's going to be the square root of 12 squared plus -5 squared, and we've already done this calculation a couple of times, and you get 13. So the magnitude of this vector is 13. Now, I know that tangent of theta should equal this over this, -5/12. Okay, now let's think quadrants real quick. If my x value is positive, but my y value is negative, that's going to put my answer down here in quadrant 4. So I need to make sure that the theta angle I'm looking for puts me in quadrant 4. So it needs to be larger than 270, but less than 360. If I go to my calculators and calculate inverse tangent of theta is going to equal inverse tangent of -5/12, and that gives me approximately -22.62 degrees. Now, our reference angle is supposed to be a positive angle, and it's supposed to be the smallest one that puts us here. Well, to get this angle, I can do 360 and then minus 22.62 to get this. Or I could add 180 and then 180 again, same idea. But you end up with this being approximately 337.38 degrees.